Today we will explore the solution for top k frequent elements. Given an integer array called nums, the task is, in addition to being given an integer called k, we want to return the k most frequent elements. And of course, the order is irrespective. So basically, for the first input example, we are given an array of integers as expected, and we're also given an integer called k. K is essentially equal to 2. And so our task for nums is to return the top two most frequent elements. Clearly, we see here that 1 appears 3 times and 2 appears twice, and 3 only appears once. So if we could rank these, we would say, well, 1 has the most frequency, followed by 2, which has the second most frequency. And since our task is to return the top two most frequent elements, we would essentially return 1 and 2. The solution to this problem, it comes in two forms, or really any form that one could think of. I'm sure there are other viable solutions, but the most obvious would be to use something called a priority queue. But you can explore the implications of that solution and then come to the conclusion that it is in fact less efficient than an order of n solution. And that's made apparent here in the follow-up, where the algorithm has to run in better time than O of n log n. And that's sort of where we introduce the order of n solution. The idea here is to actually create an array. So we're gonna the approach here is to create an array of lists. So we can imagine that this is our array, and of course arrays are numerated with their indices. And these indexes, they act as a reference to each of these particular positions. And in each array, we're actually going to have a list of type integer. And so this is going to be true for really every single individual location in the array. And what the list is essentially going to hold is it will hold the elements that belong to a particular frequency. So we could imagine that elements that have a frequency of 2 will be contained within this array, this particular location, and this list will essentially hold all elements of that frequency. So suppose, and we can sort of look at this first example. The idea here is that 1 appears 3 times. So in this position, this list is actually going to include 3. And suppose we had another sort of an element that appeared 3 times. Let's say it was 9. 9 would also come here because it appears 3 times. So the index is sort of our anchor on the frequency, and any element that appears with a frequency that matches the index will be grouped. So this is basically a grouping mechanism by which we can group all elements of the frequency that matches the index in a list that is contained within an array. Now, what's the motivation behind containing these lists in an array? Well, the idea is that we are going to, at the very end, after we actually build this array that has this property of indices as the frequency, and the list containing all numbers that have the frequency of that index. When we do this, we're actually going to iterate from the back, or in reverse, to essentially grab these lists. And why we choose to iterate in reverse is because we want the top k frequent elements. So we're looking for greater frequencies. So we're going to work our way from the back. And as we work our way from the back, we're going to essentially grab the elements in the list, and those will have a greater frequency by nature because their index is essentially greater. If we were to iterate from the front, well, then we would be grabbing elements of lists that are contained in the array that have a lesser frequency. So this is essentially, the main approach here is to create sort of this data structure that meets this property. Really the first step is to actually create, we're going to call this, we're going to call this sort of a bucket. And this bucket is going to group these elements together. And so really when you declare an array, you usually do it like, okay, let's say if I wanted to declare an integer array, I would say, okay, well, int, bucket is what I'm calling the array, equals new int, and then I would declare the length, some length, let's say 10. And inside this bucket, we actually don't want to have the bucket filled with integers. Instead, we want them to be filled with a list, right? So we'll say, okay, well, the data type that we would have here wouldn't be int, it would be list of integer. And it would be of type array list, right? So, and the length of which would be the length of the array plus 1, so that we don't essentially go out of bounds. And so this is our bucket array. And so now, as I said, it makes sense to have the frequency of each element in the nums array. And so the frequency, how would we essentially get the frequency? Because remember, what we want to do is we want to say, okay, well, bucket of some frequency, what we're going to do is we're going to access the list that is contained in each of these. Like if I do bucket, the name of the array, and then I pass in an index, well, I want that index to be a frequency. And that frequency, once I do this, I have access to the list that is contained at that location. And so I can say dot add the element, right? Nums of something, right? Whichever element I'm on. So it makes sense to actually get an anchor to the frequency in general. So we need some way to get a hold of the frequency. And so the way in which we are going to do that is we are going to create a map, right? And so this is a frequency map. We're going to use the hash map where the key is essentially the element, any given element, and the corresponding value will essentially be the frequency at which that number occurs. So we can create a map, and of course this map, it maps integers to integers, where the first integer is the element, and the second integer is the frequency at which it occurs. And this is, of course, a hash map. And after we do this, we can start iterating through the array. This is actually what we would call an enhanced for loop, where we actually don't have to. I mean, we could write int I is equal to 0, I is less than nums dot length, I plus plus. We could iterate through the array that way, but for the sake of simplicity, we can say int n. So as we move through the array, each and every single element in the array will be stored in this integer n in the nums array, right? And what we do is we say, okay, well, that map that we created back here, we're going to say, okay, well, map.put, well, what do we put? Remember, the first entry is the element itself. So that's n. And then the second entry is the frequency at which it occurs. So I don't know in advance what frequency it occurs. Like, I have to build this frequency up. Every time I see it, I want to add 1. So I'm going to say, okay, well, the first entry is the number. Then I'm going to say map.get or default. So this is, I'm either going to get what the frequency of n was before, or I'm going to default it to 0, and then I'll add 1, so that since I've seen it at, since I'm on it currently, and if it doesn't have if I haven't entered it before, if I haven't counted it before, if it's new, then I'm going to default it to 0 and add 1, so that since I've seen it my first time, it will have a frequency of 1. And then the second time I come around, and let's say that element n is the same thing, well, I'm going to put the element, and then I'm going to say, okay, well, get what it was before and add 1 to it. So this kind of takes care of both cases here. And of course, like I said, I mean, you could say, for an I is equal to 0, I is less than nums dot length, I plus plus, and then you could say map dot put. So you could say map dot put, you could say nums of I and then map dot get or default it to get or default nums of I, or default to 0, and then add 1. So either way works. It's just that syntactically int n and then in nums, this is kind of a more concise way of saying that. So just put n or map dot get or default, get the value it was before, or just default it to 0 and add 1. So now that that's out of the way, really we want to be able to start building this. So the idea is that we are going to, so this map here, right? We know that in a map, you have a key, right, of something like X. It maps to some value, let's say Y. So what we're going to do is we're going to iterate through these keys, right? We're going to iterate through the keys of the map. And of course, the keys of the map are in fact just the elements. And so the idea is, okay, well, you say, all right, well, int integer key value, or you could say each key in the map that we created in the set of keys, or the key set. What we're going to do is we're going to iterate through these keys, right? And the idea here is to say, okay, well, what I want to do is I want to say, okay, well, I want to be able to say, okay, well, bucket of some frequency is equal or dot add the key. So what does this line do for me? It says, okay, well, you have access to the key, which means if you have access to the key, then you can get the value associated with that key. And that value associated with the key is, in fact, the frequency at which that element occurs. And the element is the key. So once I have the frequency, I can say, okay, well, bucket of frequency. And then I have access to the list. As soon as I say bucket of frequency, I have access to the list. And then I can say dot add. Well, what do I want to add? I want to add the key, so that I go to the index, which is the frequency that it occurs. Then I go to the list, and then I say dot add that number, which is, of course, nothing but the key. So the key is sort of playing a multi-role here. But I don't actually have the frequency, so I actually need the frequency. So how do I get the frequency? I say int frequency is equal to, so how do you get the frequency of any particular element? Well, we have the map that maps the frequency, or maps the element to its frequency. So I can say map.get key. If I say map.get key, I essentially get the frequency at which the key occurs, or in other words, the frequency at which the element occurs. So this gives me the frequency. I can say bucket of frequency dot add the key. Now there's only one problem here. Essentially, when you first create the bucket of lists, all the entries are actually null. So they don't actually contain the list. They actually contain null. I want it to contain a list, but that isn't to say that it does contain a list to begin with. In much in the same way that when you create an array of, let's say size 10, you're actually just creating an array of zeros, right? And so it gives you, since this is a it's a primitive type, it's not an object type, it simply puts zeros in each of these entries. But since this is an object, list of integers, an object, we actually get null instead in each of them. So each of these entries have null. So the problem with saying bucket of frequency dot add key is that it assumes, this line of code assumes that that list already exists there, when in fact it doesn't. It starts out as being null. So you can't actually say bucket of frequency dot add key without there being a list there before. Otherwise, when you do dot add on it, well, it's going to give you an exception because that list doesn't exist and you're trying to add to a list that doesn't exist. So what you really have to do is you have to say, okay, well, if bucket of frequency is null, so if bucket of frequency is null, then you want to go to bucket of frequency. And what you want to say here is new array list of type integer, right? So what this does for you is it says, okay, well, so I have the frequency in hand. Like I'm iterating through the keys, which in some sense is to iterate through the nums array. And if I have the key in hand, I can get the frequency. All I have to do is just say map.get key, and I'll have the value in hand. And that value is, in fact, the frequency. But if the bucket of frequency, right, if I try to have frequency refer to the index, and then in some sense then to refer on a higher level to the list, if that is null, then I actually want to say, okay, well, go to bucket of frequency, which I was trying to access, and create a new array list there. So that later on, it makes sense to do bucket of frequency dot add key. So by this point in time, just going through this for loop, you have an array list where inside each of these array lists, there are the elements grouped together that have a frequency that match the index. So every element that has a frequency of 2 is going to be appended to this list here, or added to this list. And so that's really the first part of it, right? The second part is, well, you know, the task is not to return this list. It's to return an array of the top k frequent elements. So I'm going to create an array. It's going to be called result of type integer, right? And that's really the return type, as you can see in the method header. And it's going to be of size k, because I only want it only wants k solutions, right? And so I create an array of size k, and the idea now is to actually iterate from the back. And this goes back to what I was saying before, which is iterating from the back allows you to grab the groupings, the list that has the elements grouped together of the highest frequency. If I wanted the least k frequent elements, then I'd iterate from the front, but I want the top k frequent elements. So really I iterate from the back. And so I'd say, okay, well, int res is my array that will store those, but I have to iterate from the back. So what I do is I anchor an index on the end of the array, and I'm gonna be decrementing I instead of adding I. Usually a for loop you'll see like this. It anchors at the beginning, and then it can go for the length of the array, and then it will add to it. I'm going to subtract to it, and then I'm going to keep doing that until it hits 0. And so the idea here is to say, okay, well, as I move from the back, I grab the lists that contain the groupings of the elements of the frequency that matches the index. But the problem is not every element, not every list is not every list exists. Some are null, right? I mean, going through this example here, every single entry in the bucket array doesn't already have a list contained within it. Only those that have a frequency that matches the key, or that have a frequency that matches the like I have to anchor myself as I'm moving through the array nums. I get the frequency of it, and then I say, okay, well, bucket of frequency, right? But I haven't done this for every single element. I've only done this for however elements I see in the array. And so it could be the case that I have some null spaces here that actually don't already have a list. So what I have to say is, okay, well, if bucket of I, and this is in an if statement, if bucket of I is not null, then it's safe to essentially grab the list. So I say, okay, well, for each integer n in bucket of I, remember bucket of I is the list. It makes sense to say, okay, well, res of some index is going to equal that element, right? N. So this is me iterating through the list that I have access to through bucket of I. But the problem is, how do I keep track of the index in the res array? So I can say int index, you can say this is the res index, right? Res of the res index is equal to the element that I have. And maybe I'll make this more descriptive. I'll say element instead. So res, I'll say element here as well. So this is me iterating. The outer for loop is me iterating through, or really from the back of the list array. And if that bucket is null, essentially, If it's not null, then I know a list exists there. And if a list exists, then I iterate through that list using an enhanced for loop. So for each element in bucket of I is just the list that bucket of I refers to. I say, okay, well, res of res index, this res index allows me to keep track of the index in the res array. It will equal that element, right? And then I actually have to increment res index, right? Okay, but then I need a counter because I only want to do this k times. So I say int counter equals 0, right? So at every time I do this, I want to say, sorry about that. I want to say counter plus plus, right? And counter essentially keeps track of how many elements we've actually appended to this, or added rather to this res array, this result. And if, of course, this counter is ever k, right? If we've reached our maximum here, if the counter is ever k, and then we'll just return the result, right? And so obviously here you can also return the result, although I think this would be unreachable because we're guaranteed a solution. And so we should ideally stop here. This array was really for demonstrative purposes, but just to recap, we create that list, that bucket array of array lists. They all start off at null initially. And then the mapping allows us to map a value, or rather an element to its frequency. And so this is just a standard way of doing that. We iterate through the set of keys, and we grab the frequency of a particular key. And the motivation is then to just say, okay, well, we'll treat that frequency as an index. So we'll say bucket of that index, which is in fact the frequency. Bucket of frequency gives us access to a list that's contained in that location. So we'll say dot add key, right? So we'll access that list. We'll use the dot add API, and then we'll say, okay, well, I want to add that key. That key is just the element, right? But of course, sort of a precursor to that is if bucket of frequency doesn't actually contain a list, in other words, it's null, well, then we'll use that location and we'll create a list there ourselves. We iterate backwards. Of course, we begin by creating that result array that the output expects. We have two counters here, or really not two, but one integer just keeps track of the index in res in the resultant array. And so every time we add to the resultant array, we intend to increment this, right? This allows us for the index to reference a new location. We have a counter. We only want to do anything k times. We only want k entries, right? And so this is us, the outer for loop. We're iterating from the back. And if bucket of I is null, right? In other words, if there isn't a list at a particular location, because for whatever reason, I mean, let's suppose a number isn't present in the array, in which case, bucket of I would be null. If that's the case, then, or rather, if it's not the case, we leverage a for loop, and then for each element in that list, which is in fact bucket of I, we can take the resultant array and we'll say, okay, result of res index will equal that element. We'll increment res index. We'll increment the counter. We continue doing that really. And if the counter is ever k, then we'll just return the result. And then that should be that ideally. Another thing one could infer here is that, well, res and counter, they more or less play the same role. They're incremented really the same amount of times, but this is more clear. And so we can say, okay, well, we can remove counter entirely from from this assessment here, and we'll say, okay, well, if or really it might make sense to just retain counter and have counter also act as the it can also act as the index for res, so that it kind of plays a multi-role here. Res of counter equals element. If the counter is k, return the result. You can actually post increment, so doing counter plus plus in addition to, or also counter plus plus, these do the same thing. So you can say, because after this whole entire line is executed, counter will be incremented by 1. And so this too would also work. although I think we've introduced something of a typo here. And that also achieves more or less the same thing. And so that is top K frequent elements. And there you go.